Welcome again, everyone. Now we're going to dive into creating CK apps. What do you need to get started? If you're a developer interested in building privacy application, what do you need to know? Okay, so again, my name is Samuel Castro. I'm developer at Scroll. And what we're going to be doing today is something like this, not exactly like this, but imagine that you have this, like, for example, an ERC20 token transfer function where you can add that private fields or parameters. For example, you can anonymize the sender or the recipient or even the amount of tokens transferred. Like, this is not possible on the EVM because, of course, everything is public. So we're going to learn how to do this on the EVM, but it's not going to be exactly like this because, of course, it's not possible. The EVM is not equipped to do something like this, but we're going to approach. So what we're going to do first, we're going to build a circuit. In order to do privacy applications with zero knowledge, we need to understand what circuits are. We're going to handle that in a moment. Then we're going to be doing a demo, a very simple demo with like your hello world application by writing a circuit and then combining with Solidity because you can combine them. And then we're going to map out how you as a developer, what things do you need to learn if you want to build a privacy application that can be either voting application or like private votes or private DeFi, private messaging, for example. We're going to map everything that you need to understand. And then I'm going to do my personal opinion on what is the current state of CK and also what are we looking forward to, what's coming in CK, what's the future of CK. So what is a circuit? So for us developers at the beginning, it can be a little bit weird because how we're used to work in programming is you have a function and you have some parameters, parameter X, parameter Y, then you do some computation, and then you have an output. This is how we are used to work. Circuits work a little bit different. So in circuits, you have the parameters and the result, like the inputs and outputs as parameter, all of them as parameters, and the circuit checks that if you send this parameter, you will get this output, and if checks basically makes a lot of assertions, a lot of tests, and a lot of checks that everything is okay, and if everything is okay, it will generate a valid proof. So yeah, it's a bit different because, as I mentioned before, usually think in terms of input-output, but here the input and the output are parameters to the circuit, and then you will generate a proof. Other than that, it's very similar. The syntax is a bit similar. So what do you need? What are the fundamental parts that you need in order to build a Seeker project? So you need to learn how to build the circuits, this is the new part. This is what we're going to be doing today. Then you need a verifier contract. We're going to talk about that in a moment. And then you need Solidity logic. And in this point, if you are already a Solidity developer, you should be very familiar with this. But yeah, so the things that you need to understand is how to build a circuit and how to verify that contract. In terms of the most basic application, it usually is a front end with private inputs and WASM prover. So this means that you will make off-chain computation on your browser, and it needs to be on your browser, although we're going to talk about some alternative later, but it usually needs to be on your browser to keep your work private. Yeah, because if you send it to an off-chain or to a cloud or on-chain, it's going to be public. So it's very important to do a WASM program. WASM is the WebAssembly that you're running on JavaScript on your browser, and you need to generate the proofs there so they are private. Then you have the contract, and here you will need your Solidity skills to create contracts that are able to process and to compute and verify stuff, even if they happen in a private environment, which I think is very interesting, right? So now we're going to do a demo. We are going to do the simplest of all. We're going to be using Circom, and we're also on the show notes, you will be able to find this. So in Circom, yeah, you're just going to build a very multiplier application, the hello world for Circom, very simple. Then we're going to move into a more advanced application, so you can first learn the fundamentals and then learn how all the architecture looks in a more advanced application. I already have installed Circom, but yeah, you can install it this way. So I'm using Node version, I'm going to use version 20, and then I'm using version 0.7.2 of Node.js. So yeah, I'm good to go. You should just paste all of this and you should be able to also have Snark.js. So first, we're going to create this circon file. So I'm going to open my favorite editor, and I'm going to create this circon file. Then I'm going to, this is the circuit. As you can see, it's a bit similar to coding. Here, we're just going to have input A, input B, and output C. C is going to be A times B. So we're going to generate this computation, but A and B is going to be private. So we're going to prove that we created a computation without revealing the inputs of the multiplication. We are going to only reveal the output. And by reveal, C is going to be available on the smart contract. A and B is not going to be visible. All that computation, this small computation is going to happen on your browser. On future applications, you can think it as maybe is A and B are the sender of the ERC20 token contract, and C is only the amount. So you have public and private inputs, and you can create computation that happens on your browser. In this example, we're going to do it in the terminal, but regardless, you can like divide it. For example, on a voting application, you can have sender of the vote private, and you can have the vote itself public, so it can be counted. You have many, many interesting things that you can do here. But yeah, let's just start with the basics and just focus on generating a proof of execution, giving a couple of inputs. Now we create the input file. So here we're going to set up A and B, 3 and 11. So C is going to be, of course, 33, the multiplication. We're going to save this here. And now here I'm going to do the whole process. It's going to take not too long, but just going to take a bit. And what is going to happen here, first is going to compile the circuit. It's going to ask me for some entropy. You may have heard of the initial ceremony for creating a CK circuit, which ideally you will have many people contributing randomness or inputs. So the thing is that many people can participate. The system will be secure as long as there is at least one good actor. So usually when you deploy, this is called Grot16. We're using like in the backend, like behind the scenes, we're using something that's called Grot16. If you're using Grot16 in an application, you will need to just do this ceremony before deploying your contract, which will make it safer. You can also like lean in some ceremonies that people did in the past. There are Ethereum Foundation also did one. Alternatively, you can use like entropy or random inputs. So I give him more. And what I was saying is that there's also new technologies such as Plonk that don't need this initial step or the Starks, I mean, that don't need this initial step. But yeah, there's different technologies. Some are cheaper to verify, some don't need this initial step. So like a lot of pros and cons on every technology, which I think it's good to understand. Of course, this is evolving and there are new technologies coming from time to time. So now we're ready. Now we're going to run this command, which is very, very interesting. This generated a lot of files, but the one that is going to interest us is this verifier.sol, and you may be guessing what that is. And it's a Solidity file. It created a Solidity file by itself. This is not code that I wrote. It's just a lot of like mathematical stuff that will verify the proofs on Solidity. So what we're going to do, we're going to deploy this contract. And this is why Scroll is a great candidate for deploying Solidity like verifiers, because the only CK EVM that supports this very weird mathematics stuff is Scroll. Is the only CK EVM that's able to support this. So yeah, we're very excited because we prioritize everything so that you're able to deploy and Scroll. So now I'm going to go to MetaMask, and just as the way as we did before, I'm going to just deploy this verifier smart contract. So right now I am in Scroll Sepolia. I have some testnet ETH. So I'm going to go to injected provider. Oops, my remix is not working correctly. This happens all the time. So I'm going to recompile it and choose injected provider web3. Now it's working. And I just deploy this contract as is. I don't make any changes. Now, this is just going to be able to verify the proof. So this will have a verifier proof function. And as you can see in the commands that I share with you guys, I also generated a proof like this that I can verify here. So it returns true because the proof is valid. If you change any number here, it's going to revert. So what you are going to usually want to do on your application is to have a what I like to call a custom logic contract. A custom logic contract is where you can add your logic code. So if you have an ERC20 token that has privacy features, you can manage the balance on your contract. If you are making a voting application with privacy, you can resolve the vote results on the smart contract and keep the voters private in off-chain computation, which is very interesting. We're going to do we're going to check out a more advanced app in a moment. This is what I like to call the custom logic contract. And what the custom logic contract is you can send him a proof and two things. First is verify the proof, and verify the proof using the other contract that we just deployed. And secondly, you can make your custom logic based on the public input. So the private inputs are computation that you are not able to see on the smart contract because everything on the smart contract is public. But you can verify, you can get some public inputs on your smart contract and you do the rest of the computation that you want to have on chain and secured by a smart contract. So we're going to deploy smart contract. As you can see on the constructor is asking for the verifier that we just deployed. So I grab the contract here and I deploy. Now, when it gets confirmed, we'll be able to also send the proof, just like we did before, but we're going to do some extra computation with just storing the public inputs. As you remember, we were multiplying, let me check here, we're multiplying 3 by 11. So this is private. It's not visible for a smart contract, but the result is visible. So we multiply A and B without revealing them. We only revealed C, which is 33. So when I passed the same proof that was validated before here, is going to, in the background, is going to send it to the circum verifier that we deployed before, and then it's going to store that number 33 as this is what I define as custom logic. So here you go, it is stored. So yeah, this is the basics. I know this may be a little bit confusing if it's your first time. Don't worry, this is because it is a new technology, but I really invite you guys to learn more about this because this is has a lot of future. And also, if you want to deploy something on Scroll, feel free to connect with us because yeah, Scroll, as I mentioned before, it's a great place for deploying privacy applications. Now, I would like to show you this other application that is more advanced. This is a private messaging tool. Basically, you will send a message. Here, these are some comments that are stored, and this is going to be using your MetaMask account. And you will see in a moment that it's going to take a long time. So I'm going, because the state of CK is very new, but it's improving. It's improving with time. It's improving very fast. So I'm going to send this new message, and I'm going to sign this message. As you can see, I'm signing this message here. I'm going to sign it. And the thing is that how this works is now it's generating a proof, and it's going to take a very long time, because how this application works is that this is called an anonymity set, where you can only post in this anonymous message board if you are part of this group. For example, if you are an NFT owner, if you have certain amount of tokens. In this case, is if you are part of this list. Only if you are part of this list, which by the way is a Merkle tree, but don't worry about that now. Only if you're part of that list, you're able to post. But when you post, you prove that you're part of the list, but you don't reveal which one you are. What we're going to generate here we just sign a transaction and we generate a proof. But this proof is going to be automatically sent for us. But how is that possible? That is because we're using a relayer. And that's why I would like to introduce to you guys a couple of new terms here. So this is how a complete typical CK application works so you as developers can just play around with this. So imagine that you want to anonymize yourself. For example, in this application that I'm showing to you, this simple chat application. The problem is that if you anonymize yourself but you are the one yourself that you're sending a transaction on chain, you will dox yourself, right? You will reveal who you are. So that's why we need a relayer. The relayer is an intermediary. You just sign the transactions to prove that you're yourself, because we are proving that we are a specific, in this case, MetaMask account or Ethereum account. So you are proving that yourself, you are one of these accounts without revealing which one you are. Then you generate a proof on your browser using a wasn't prover. As you can see, now we are generating the proof here, but the proof we generated, this is the big proof, and the proof, very, very importantly, is that the proof was generated on your browser, because from the point that you send the inputs to the proof generation, everything, you have private inputs. But after your proof is generated, you can send the proof whatever you want. No one is going to be able to see private inputs, which in this case is your signature, your identity. So if I refresh here, you will see that my comment was added here. But never in this process, I send the transaction on chain. Never I pay the transaction fees. How this transaction was sent? This is because I'm running a relayer node here. So this relayer, which is very simple, it just receives a transaction, is running locally, receives a transaction, and then sends it on chain. So I can grab this and go to Etherscan, and this transaction was sent not by me, but by the relayer. So this is very important because this will keep you anonymized. The relayer not only applies only on CK, but also, for example, on CowSwap, for example, from the Gnosis team. They have relayers for DeFi applications, or even rollups and layer 2 have relayers to send the batch transaction on chain. You need to find ways to incentivize them. In this demo, I will leave you also the link to the code so you can check it out. And this very, very dumb relayer, it just relays everything, but you have to look for a way to incentivize him too, right? So on the front end, you have private inputs that get anonymized and you generate a proof. All the private inputs are going to be obfuscated. And then this proof is sent to a relayer, and the relayer will send a transaction on the smart contract on chain with the custom logic. In this case, the custom logic is just handling the comments. And there is one also extra possible tool that we as a developer have. So we have some CK proof computation. So as you could see, the generating a proof using Ethereum accounts right now is very computer intensive. There are new papers that are coming that's going to reduce the time, but of course, that is still a problem. Potential solution for this is CK computation. So you send your inputs to the proof computation system like Cloud, and they will generate the proof for you because they have like ASIC, or I don't know, maybe very good processors or video cards, depending on the type of the proof. They have the best hardware for that, and they will generate the proof for you very quickly and then send the result back to you. Of course, if you do this is not compatible with privacy application. Remember that CK can either be used for privacy or for scalability. So maybe you want to aggregate transactions. This is also called recursion or aggregation. And there are different things that you can play around with this, so you can use that. So this is like the complete landscape of everything on CK. I know this is a very dense video. I want to motivate you guys to learn more and don't feel that you're too lost and this is not for you, because this is new for everyone. This moment, this is a very new technology with a lot of potential. You can do a lot of things with this today. But you may be asking, why aren't there many CK dApps there? Why aren't there many CK privacy application built today? So there are some limitations that I'm going to mention right now. The three limitations that I see, one is regulation uncertainty. As you may have heard, what happened with Tornado Cash, it got shut down. But remember that zero knowledge is such a big technology. It can not only serve to anonymize yourself, but also you can, for example, prove that you are not part of the anonymity set, an specific anonymity set. For example, you could prove that yes, these are funds that you store funds in a mixer, for example, but also prove that you are not part of the bad guys, let's say, of people that the regulators don't want you to interact with. You can also prove that. And so zero knowledge is a big technology. Also, the regulators are starting to understand more the benefits of the blockchain technology in general. So I think this, with time, will be eased out. But yeah, something to keep in mind at this point in time. Secondly, is as you could see in this example, it took a long time to prove, especially if you are dealing with Ethereum accounts or Ethereum related stuff, because Ethereum relies a lot of some hashing functions that are not compatible with zero knowledge. Sometimes you have a very long proving time, but one, this is improving, and also there are new technologies that are coming, new papers that will be implemented that make proving faster. Yeah, you can also do cloud proving, which is very cool. And also, other thing which I didn't mention in this video is the lack of nullifiable signature adoption. So we need the wallets like Ravi, MetaMask, everyone else to adopt a new like CK friendly or new nullification friendly, which is something that will give a user a good user experience, user their own wallets. So yeah, right now there is very limited what you can do with the current wallets on the market. They need to implement some extra stuff, but yeah, hopefully they implement it fast and we can like see the benefits of this. Or also this can be bypassed with account abstraction, but that's another topic for another day. Thank you everyone for making this true, and yeah, I hope that you like learn something, and also I hope that you get motivated to just start building on CK. And if you start building on CK, reach out to us in Scroll, because very interested to see what did you tinker with this technology. See you soon.